Okay, in this exercise, we're presented with this fairly simple circuit here, and we're asked for a couple of things. The first thing we're asked is to determine the equivalent resistance to the right of terminals A and B. So here's A and B. So if we look to the right of those, that means we're looking in this way. What could we replace those 5 resistors? What single resistor could we put in their place as the equivalent resistance? So let's look at that first. So as we look at this, the first thing we see is the 2 and the 18 are in series. So we know that when 2 resistors are in series, we can simply just add those. So by adding those 18 and 2, we get 20. So then we could replace these resistors then with one resistance or one resistor, which is 20 ohms. So there we have 20 ohms. So now we see that we have this 20 ohm resistor and this 5 ohm resistor in parallel. So we know that we can replace that with a equivalent resistance by saying 20 times 5 over 20 plus 5. And so when we work this out, this will be 120 over 25. Oh, excuse me, 100. So that's 100. 100 over 25, and that gives us 4 ohms. So now those 2 resistors can be replaced by a 4 ohm resistor. So we will look to replace, we don't need this side at all anymore. And this right here, we can replace with a 4 ohm resistor. Sorry. 4 ohm. We'll connect that back. Okay, so now we see that we have this 2 ohm and this 4 ohm resistor in series. So again, when they're in series, we just simply add them. So 4 plus 2 is 6. So therefore, we should be able to replace those 2 resistors with just one. So we'll get rid of this one and change this value, and that'll be 6 ohms. So coming back here, making this connection, and then this will be 6 ohms. All right, so finally, we have 12 ohm resistor and 6 ohm resistor in parallel. They share the same input and output. So therefore, we can calculate our equivalent resistance, because this is what'll be, this is all that's left. That'll be 12 times 6 over 12 plus 6. And when we calculate that out, we will get 72 over 18, and that is simply 4 ohms. So finally, we can replace all of this with one resistor, and that one resistor is 4 ohms. So then that will be 4 ohms. So there. So now we've solved the first part of this equation. It's 4 ohms. And so but now they've asked us to calculate V and I. So V, which is right here, we can do quickly while we're here. This is just Ohm's law. And so Ohm's law says that V is equal to IR. So in this case, our V is going to be equal to the 5 amps, which is the source right here, times our equivalent resistance, 4 ohms right here. And so that gives us 20 volts. So that means the voltage across this from A to B is 20 volts. We can write 20 volts up here. All right, so we found V. So now we have to go back to our original circuit. So let's go back to that. So here we are. And so now they are asking us to take the knowledge that we have now and calculate I, that current running through the 5 ohm resistor. So this isn't straightforward, but we can come up with a valid approach. So again, we know that it's from here to here is a 20 volt drop, right? And we recall that this little part right here ended up being a 20 ohm resistor in parallel with a 5 ohm resistor. And we can go back and see that when we calculated that, that was a 4 ohm resistor. So what this amounts to then is we can think of this as our 2 ohm resistor, which our 2 ohm resistor, which we have right here, and this branch, these two branches, I can replace with a 4 ohm resistor here. And so that being the case, I can determine what the current is flowing through the 2 ohm resistor, which will be through this whole branch of the circuit, again using Ohm's law. And so we know that I is equal to V over R. In this case, we said that the V was 20 volts, and the R is going to be 2 plus 4, which is 6. So it's 20 over 6, or 10 over 3. So 10 over 3 amps. Okay, so that's the current through this, that's the current right here through this 2 ohm resistor, but it splits up when it gets to this point. Some goes this way and some goes this way. Well, we have a relationship when we have two resistances in parallel of how the current splits up. And so we're going to call this I5. And so in that case, I5 is going to be equal to the resistance on the 20 side over the resistance on the 20 side plus the resistance on the 5 ohm side times the total current I. So in this case, that will be 20 over 20 plus 5. And that's going to be times the current coming down to this node right here, which we said was 10 over 3. And so when we multiply this out, we will get 200 over 75. And our numerator and denominator have a common factor of 25. So if we factor out 25, we'll get an 8 on top and a 3 on bottom. So 8 over 3 amps. So that's what's flowing in this leg, 8 over 3 amps.